So, good afternoon, everyone. Thank you for joining us for another Mathematics Power Hour, productive conversations to really unpack the Florida B.E.S.T standards. Now, we acknowledge that the standards by the state level was unpacked, but for us, it's really thinking about making sense of it for our reality, for our spaces, and also think how could we best move this forward in a productive and a collaborative fashion. I am pleased to be joined by my phenomenal colleagues, Dr. Sandra Vernon-Jackson from the University of South Florida, St. Petersburg campus, and our Mrs. Beth Smith from Texas Instrument, who has been a phenomenal collaborator and really a wonderful ally in really thinking about how could we advance Florida B.E.S.T standards across the state of Florida. The topic today focuses on using students' misconceptions to develop mathematical thinking and reasoning standards. So we're going to really zoom in on this construct of the notion of the error, or we talk about the conception that's misunderstood. So in this regard, next slide, please. So Sandra, you want to give us a review as to the standard document for the MTRs?
Sure. Good evening, everyone. And I'm so excited that you all were able to join us this evening. I want to make this as interactive as possible. So please feel free to put questions in the chat or just turn your mic on if you have questions. So if you look at the trajectory that the district has placed out, you'll notice some very interesting information about how certain benchmarks and standards will be going straight across. I want to ask you real quick, if you could just tell me from the first piece right there talking about the progression, what do you notice about the progression that's there? Any thoughts, any ideas? You want to drop it in the chat or turn on your mic and just give us some thoughts about what you notice.
Matt, your mic is open. You wanted to say something?
Sure. We have specific, there's more information compared to the Common Core standards. We go very specific in high school with financial literacy, trig, logic and theory, and calculus standards.
Okay, thank you.
And actually we have fraction standards where I believe that was under number sense and operation. So it's kind of like, I kind of look at it as our new B.E.S.T standards are more, it's like they're chopped into smaller pieces compared to what we had in our Common Core standards.
Okay, all right, thank you, Matt.
It's not like we can, they're not like one-to-one, but it's kind of like, it's making it more teacher-friendly.
Teacher-friendly, okay, thank you. I cannot see the chat at all, so I'm wondering if I saw that there are two messages in the chat. If one of my colleagues will just tell me what's going on in the chat, I would really appreciate it. Any other thoughts?
Yeah, so my definitely noted 4 content areas extend through K through 12. So there are 4 big ideas that goes across the K-12 spaces. And one of them is the MTRs.
Absolutely. And so thank you so much for that. So as I'm glad someone talked about or brought the idea of the MTR, the mathematical thinking and reasoning standards. I want to make sure that I point out the fact that these particular MTRs are really to help our students, right? To kind of assess or have an idea of where they may be. It is really for self-assessment for the students of their experiences as they're going through their mathematical instruction. It is also gives teachers clarifications, right? You can use it to kind of have an idea, a perception of exactly what is going on with instruction as you go through or read, or sorry, as you go through with your students with the instructional pieces. So this will help us as we start to think about misconceptions and think about reasoning as we go through math throughout every progression, every benchmark. Next slide, please.
So considering we're going to be focusing on misconception, let's look at this Dilbert cartoon very closely by Scott Adams. So the boss said, a study says 74% of managers think they are above average. That means 36% of managers aren't aware that they are above average too. The way I look at it, you're all in the top 110%. And he said, exactly, thank you. So my question is, what two errors does Dilbert manager makes in the second frame? And describe the sarcasm in Dilbert's comment and his manager's response in the third frame. So what do you notice in this cartoon? Like, what were the errors in the conversation? What were the errors in the conversation? You can raise your hand, or you can drop it in the chat, or you can just open your mics. It's up to you. All right. So the error in this regard, it's really fascinating. So as we think about it carefully, exactly. So Carrie said 74 plus 36 does not equal 100. So that was he was correct. So they were adding above it. And so in this regard, Dilbert is being sarcastic when he said it's 110%. But that makes no sense because it's greater than the population. But his manager agreed. Thank you. Because many times some individuals cannot even recognize the error. And so with misconceptions, there is this construct that we're making sense of information. So it's a conception, but it could be a misalignment. So we talk about even with proof schemes, or you're making a connection, but the connection may be flawed. So in this regard, we have to think about how do you make sense of this space? Now, what's fascinating with the Florida B.E.S.T standards, they actually start specifying misconception. And I thought that was very beautifully done because it gives us an opportunity not just to focus on the content, but addressing common errors in our planning for instruction. And so as we think about what are the common errors, where are those schematic disconnects, or we call it the error in logic, that we have to address up front, we can think about how to plan our instruction more productively. Next slide, please. And so let's look at this carefully. This is another clip. So the two students are side by side. This number is the largest, I think. He's referring to 0.67. And the students say, yes, it has the most digit, although he's standing next to the side of 0.8. What is their understanding? So we acknowledge what is the flaw, but what are they showing you they have an understanding in mathematics? What is their understanding in that space? Deanna? Yeah, so Deanna, they think the more digits, the greater the value, or the amount of digit increases the value. And so they are showing some level of knowledge because for example, if you have natural numbers, 2-digit numbers are bigger than single-digit numbers. So they are showing some level of conception. But the problem is they're also showing an error with their understanding of place value. So in this regard, this is where as teachers, we have to reflect on what knowledge they're showing as well as what is the error that they're showing. So for the big M, the section focuses on misconception or error may include strategies to address the identified misconception or error. So that was very intentional. So they recognize these misconceptions and error to enable educators to identify them in the classroom and make efforts to correct the misconception. So this corrective effort in the classroom can also be a form of formative assessment within instruction. So the question is, how do we use these errors to support student learning? So formative assessment is for learning, summative is off learning. And so in this regard, sometimes you may put it as a part of the lesson where persons have to think about the error. Other times you say, okay, based on this, what are they showing? And this is where your rubric kicks in. How do you account for this mistake to support their learning? Next slide, please. Sandra?
Yes. Okay. So as Ruthmae said, So how do we assess these errors, right? What do we do? Well, the intent here is to build a culture, a particular type of culture in the classroom where students' errors are just as important, right? So what Joe Bowler talked about is the growth mindset culture. And this is a culture where the messages are consistently given to students, that you are reminding students that, first of all, in the first extended portion is that your ideas, your thoughts, your efforts will be validated, right? No matter if it's a misconception. So you remember Ruthmae asked, what does the student really understand so far? And individuals point about the idea that digits, that the more digits they are, the larger the number. So there is some conception, and what Bowler talks about is valuing those particular efforts, giving praise to those particular efforts, being very, very intentional and consistent, not for some students, but for all students, right? It helps the teachers to create a type of solidarity and strength, but also place the students in that journey of what you are learning. It is important. And the fact that even with your misconceptions, whatever those pieces are, it has value, because when you start talking about those misconceptions, right, it brings light and helps the students and the teachers to strengthen whatever concepts they have, and also debunk those misconceptions. Another thing is, again, giving power to students, allowing them to evaluate themselves in terms of the growth mindset. And there you see to the right of the screen, there's a rubric that Bowler came up with that she thought would be great to give students as they start to evaluate themselves in a growth mindset. The area is here to have students strengthen whatever it is, whatever concepts they have. We want to make sure we strengthen and build that growth mindset culture. Remember, the idea is answers have value, and to every pathway that is in the brain that is being formed, it has a purpose. And so that's one of the idea behind this particular rubric, is to also give students the power of identifying where they are within the growth mindset, while the teacher is also helping to evaluate themselves as well as they move towards the strategies, the praise, as well as the student's mindset in identifying concepts and misconceptions. Next slide, please. And so what came out of that? Now, I know for me, when I was in the classroom, one of the things that I learned as I'm going through is that in order to help students or identify exactly where students are, I have to be very intentional, very purposeful about the questions I have posed to my students, right? So here are these 5 strategies of identifying how you would go about orchestrating discourse in the classroom, because this is how we get to understand what students are thinking about. So the first one, anticipating, right? Anticipating is basically identifying. Give me a minute, you're on my screen, just went black. I'm just gonna talk, screen went black, I don't know why. Okay, so anticipating, determining possible student solutions, right, and strategies, identifying what is correct and what is incorrect, and deciding how the student's approaches relate to whatever the goal may be. So the teacher therefore has to consider how you will respond to various things or approaches or strategies that students have. The next one is monitoring, right? We all do this. We walk around and we kind of look at what the students are doing, and we have to basically prepare questions to assess whatever we see going on. So attending to what students are saying or what they're doing, what particular strategy they're representing. Selecting, deciding which response to share with the class. That is so important. You have to decide as a teacher if the common misconception should be analyzed more in depth with the students. That is very important. Sequencing, determine what order. In other words, am I going to select to talk about the incorrect response or the correct response, or the correct response versus the incorrect one? Which one am I going to present to my students that determine or would allow them to achieve whatever learning I am trying to have my students do? So being very selective in what I present to my students. And then connecting, helping students to make judgment about accurate information. So my job is to help them to identify when I would allow, right? I have to allow the questions to go on. When am I going to allow links to go in so that those misconceptions can be discussed as I am going through my questions, which are very intentional and very purposeful. I am not sure. I guess next slide. I'm not sure if okay. All right. So the next slide. Okay. Hold on, you all. I'm going to let me go and just pull up the PowerPoint myself because I'm having a blank screen right now. Technical issues, and we are teachers, we are educators, so we know how to move with it. Okay. So I think the next one, and correct me if I'm wrong, is the strategy for posing questions. Okay, all right. So the bottom line here is to remember that when you're posing questions, the key idea here is to be purposeful in your questioning, be intentional in your questioning, right? The idea of, remember the strategy of posing questions for specific response. So are you going to pose questions based on students' thinking, right? So questions like, how did you find that answer, right? Or did you choose to break certain variables that are given into the problem up? So trying to get students to provide a way of their interpretation, trying to get into how they are thinking. The next idea is to generate ideas. Do we question students to help them to unpack the meaning of words or unpack the meaning of certain topics or concepts or ideas that are given in the problem? Are we doing it for them to help them gather information? So we may ask a question like, what does the problem say about whatever? Or can you show me what this would look like, right, if you did such and such? And then again, are we trying to revise or have students explain? So our question may be prompting students to notice certain particular ideas that are in the problem and probably pose, so if you did that, what if, or that type of stuff. Or can you try reading the problem in a different way? Does it make sense or not? Then have our students, the next idea for purposeful question is justifying their claim. So asking questions like, why did that solution work? Or how is the way you solve different from the way your partner or your peer over here solved the problem? So you're getting students to compare other strategies, right? Or consider non-solutions as well, because this type of purposeful, intentional question would help not only you to get through the students' thinking, but also as you asking these questions, the students themselves who are listening are identified as they go along, whatever misconceptions they may have as they're moving through their problems. Next slide, please.
So as I was listening to Dr. Vernon-Jackson, she brought to light multiple points relative to really orchestrating the dialogue. Because when you think about the misconception, if you anticipate it, where do you bring it into the lesson? But also, she asked the question, what are we asking to help them make sense of it? So rather than simply go and tell them this is the answer, she's creating a form of inquiry to create this notion of they're the owners of the mathematics, and they're strengthening their identity is to press on and correct the errors to make sense of it. So that's important. That's very interesting that she was centering it along that line. Now let's look at this scenario. The following item appeared on a quiz after instruction about the median. Find the median of the following data set: 18, 15, 23, 12, and 19. So then evaluate each of the following students' responses to identify what misconception, if any, the students had. What might you do instructionally to address each misconception? So for example, the student said the median is 23 because 23 is the middle number. What is happening in this space? What are your thoughts, Diana? How would you address that comment?
Yeah, so I was just putting into the chat, I like to have my students, I praise them for sharing their oh no moments. That's what we call when they make a mistake, and they'll be eager to tell me what mistakes they've made. So then as a class, we could discuss what approach they took and what mistakes or errors they came across. And from there, we go through and we discuss it, and I go along with it like, okay, well, what could we do instead of taking that approach? And we discuss different strategies, but I'm really big on identifying these mistakes and letting them have that voice to explain why they took that approach, where they could have made their mistakes, and have them make the discovery. Yeah, that's all I have so far.
Okay. What about the scenario? So in that regard, for the number 23, the student is showing you they know it's a middle number, but they're not realizing it has to also be a range from least to greatest. So there is a conception that's evident, but really thinking about the error is, okay, the order do matter, so restructuring it. And so in that regard, reinforcing the positive, but then showing them how could they move it forward. So you're absolutely right, Diana, where you think about ways to support them in that inquiry. What about the median is 17.4? Where did they get that answer from? Carrie said, is it the average? Yeah. So in this regard, they may be showing a construct where they were exposed to measures of central tendencies with mean, median, and mode, but they don't know the difference. And so they were able to do a calculation, but they're not applying the correct term to the concept. So in that case, they're finding the mean and not the median. And so this is where we talk about the dangers of the 3 M's, like being cognizant, how do the 3 M's differ? The mean, the average, the median, the range from lowest to greatest, and in the middle. And then the mode, the most frequent. So you may need to restate definitions based on that error. What about the median is 18? Is that correct? So when you start thinking about these errors, really thinking about not just knowing the error, but moving it in the direction where students are learning, where you're taking the error for instructional purposes, so you're using it formative for learning, rather than just saying it's wrong, but using guided inquiry to figure out ways to support the learning experience. Next slide, please. And so in the Big M, the benchmark for instructional guide for mathematics for the Florida B.E.S.T, they actually explicate for every standard, for every benchmark they gave some common misconceptions or errors. So let's look at this benchmark. Determine an appropriate measure of center or measures of variation to summarize numerical data, represented numerically or graphically, taking into consideration the context and any outliers. So in this regard, they suggest the common misconception may include calculating measures of center and variation, or incorrectly graphical display, using incorrect graphical displays, or incorrectly identify data points as outliers. So in this regard, if you know students are interpreting it wrong, you have to carefully plan for the error. Now, the Big M also gave some instructional suggestions. So thinking about how do you bridge the spaces from the benchmark to the common error to the instructional practices. Matt also suggested like CPOMs, and that's another thing. The state is making CPOMs accessible even at the university level. So they're really trying to provide the necessary support across the K-20 spaces to really think about ways to ensure the standards are enacted as intended. Next slide, please. So let's look at this data set. So here we had a data set relative to electoral votes for each state in the District of Columbia for the 2012, 2016, and 2020 presidential election. And then they gave some data support where they talk about which state is the most electoral votes, how many votes does it have. Here's a line plot of the distribution. Does the plot lead you to think any states outliers, or what measures of center you recommend for describing this data set? So looking at this data set as a whole, what misconceptions can you see students coming towards while they're engaging in this activity? What errors do you see possible? Dr. Kudasai? Your mic is muted. All right.
I'm still looking at it. I'm sorry.
I think there's also a couple comments in the chat. I just can't see that.
Oh, yeah. So like, for example, relating the number to the wrong state. That's a common error where they're actually mismatching information, because the larger the data set, sometimes just writing it wrong may be the error, and also placement. Any other misconceptions you see students may have? What about reading the information in the charts? Like, how do you interpret it correctly? So in that regard, they gave a line plot, but they may miscount. How do you interpret it? Like, what does it mean for them?
Right. I was going to add, Dr. Sears, that just seeing the table like that, students are used to seeing it where it's just two columns as opposed to the columns being stacked like that. So they may misunderstand just viewing the data in that way.
Okay, so visual representation. Now, data visualization is actually gaining lots of traction in mathematics, because we're realizing we read the language of mathematics, but how it affects the way they read it. And so that may be an issue as well. And so really thinking about, if you know these are distractions, really thinking about planning to address the misconception from the onset. And so as you think about the Big M giving instructional strategies, you may say, hold on, rather than using the table as is, even setting it up on an Excel spreadsheet so they can pivot as need be to make sense of for their reality. Next slide, please. So another component of misconception is the ability to engage in mathematical discourse. And it really helps to develop students' ultimate reasoning and proof skills, because Stalianidis highlighted that oral proofs tend to be more accurate than their written proof. And so really thinking about what are they saying in this space, because it can help us to really strengthen their reasoning and proof skills if we could correct the misconception and so use it as a tool for learning. So use it formatively. And so technology has the potential to ultimately support this space. So technology can promote cycles of proving, present and connect multiple representations, support case-based reasoning, and serve as a tutor of the learning space. And so this is why we're truly excited that Beth Smith with Texas Instrument is willing to collaborate with us, because technology can help us to address many of the misconceptions students may have. So Beth, we turn it over to you.
All right, thank you, Ruthmae. All right, I'm unmute. I think I'm good to go. So piggybacking on Ruthmae talked about, technology is awesome. And I always like to start presentations with this quote, and I haven't used this yet, so I thought tonight would be appropriate. So technology should be the servant to teaching and learning and not the focus of it. And Ruthmae talked on the previous slide, like, why do you use that? And I think that's important. So when we're utilizing technology, it's not about the technology, but it's like, how can we help kids build a better conceptual understanding? What tools are at our disposal? And I think that we need to think about that when we use technology, it needs to think with the students and not for them. And so we don't want the technology to do everything for them. We want them to be able to communicate and to think with the technology. And that's different, perhaps, when they get on a standardized test where we would want them to use a calculator to multiply 19 times 7, because we want them using their brain power to think about the fact that's what they need to be doing. We also need to make sure that the technology we use is mathematically correct. The syntax is there, that it's not doing too much for the teacher and having to think about it, that it's pedagogically sound. And what I'm going to show you in a minute is really the technology should promote exploration that turns into discovery, and should also allow the students the opportunity to verify what they think, and then give them if they made a mistake, and they learn about that through the verification, to go back and really correct that on their own. And through all this, then they're going to be developing that conceptual understanding. And so Ruthmae just talked about what benchmark we're really going to look at is the one from 7th grade. And basically, given some data, talk about the measure of spread, whether it's the center or variation. And just really quick, let's keep in mind that the measure of center, they're going to be focusing on just the mean and median, and the measure of variation is going to be limited to the range and the mid 50% of the data, which we know is the interquartile range. So going a little bit deeper, and we talked about just really going horizontally and vertically last month when we had our session. If you look at the horizontal alignment to this standard, there really was really interesting that they did really that number sense, like where is that procedural fluency when you're dealing with adding and subtracting and multiplying, rational numbers. And they also do a great job in the Big M to give you all the glossary, like what are these words that we need to know and understand, and you can see those here. And with vertical alignment, it's really important to look at, where your students should have been coming from. So they should have already really been given a set of data and been able to interpret the mean, the median, the mode, and the range. And then going on, you see when they get into 8th grade, that's where we move into basically go from, one variable data to bivariate data. So that's kind of where they've been and where we're going. And again, let's look at some common misconceptions and errors. And I think it would be, again, the bottom of this slide, you can see the fact that, just as I mentioned, we're talking about the mean and the median, and the variation as being the range and the interquartile range. And, I think for most middle school students, it's going to be a little bit tough for them to just talk about what the IQR is. And so this particular standard doesn't have them calculate the IQR necessarily, but kind of estimate those outliers. And so how can we use appropriate tools to build the knowledge of understanding? And I'm going to go back. I'm going to go back to maybe what you could do in 6th grade. And this is actually perfect timing. I was in Pinellas County today, working with teachers during their pre-planning, and was working with the teacher that was teaching math for college readiness. And she just says her students even struggle with the concept of median and what a box plot truly is. And so an appropriate use of tool would be something like, I'm going to showcase the Inspire just because I love this handheld. It's what I taught with the last 5 years I was in the math classroom. And the first thing students need to know, and let's look back at those misconceptions that Ruthmae was just talking about. If we've got a set of data, the first thing we need to do is to order that data, right? So kids need to be able to order that data, and then they need to be able to drop that data on a number line and make a dot plot or a line plot. And so there's technology tools out there that are pretty cool that the students can really go through and get, that's the first step of how we're going to organize that data. And then how does all that fit into a box and whisker plot? And so I love this concept because we've got, I need to go back to that one real quick, so forgive me. The next thing would be is, how do you really determine the median? And I would always do, you know, like a human box plot, but this would be a great precursor to that. So as we're moving this to find the median, and remember those students they got it ordered, but some of them had a hard time finding out exactly what was that median. If we know it's the middle value, then students could really look at an activity like this. A teacher could ask questions and then go, okay, we split that in the middle. That's our middle value. That's the median. We have half the scores below and half the scores above. And if we talk about the box plot, dividing it, what does it do? It divides it into 4 equal pieces. So that means, okay, well, let's take the bottom half of this data and let's divide that into 2. And so, whoops, I need to mark that. And so now we can divide the bottom half. And we get quartile 1, right? We can mark that. And then we're going to take that top half and divide that into 2. And so you look at a visual like this. This is the right use of technology to help students build that conceptual understanding. And it really changed the way I thought, in the sense that, you know, when we're putting steps up on the board, we know exactly where that point Z is. And we just go by steps, but the kids have no clue what we're doing. Whereas if we show the graphical approach, whether we're dealing with geometry or algebra or statistics, and let them develop that big picture and play and visualize it, then you know what? Take this technology away and they're going to be able to do this by hand. So that would be kind of the precursor, and even box plots in general. And so we've got some great data here, kind of all spread out. How would we make that into a box plot? So let's summarize it. And so students can see where all this data fits in. And if we click on that lower 25%, we can see what data points fall there. All right, that 25 to 50%, and so on and so forth. And then students can really see that visually. But what's awesome is, why not, instead of talking about the interquartile range from the get-go, let's talk about the middle 50% of the data, because that's what the interquartile range really is. So use some more simplistic terminology with your middle school students, where they understand that, oh, okay, the middle 50% of the data, that's our interquartile range. And a simple visual like this that shows this to our students. So thoughts or comments about what this could maybe do for visualization and students developing that understanding. It's pretty powerful.
Carrie wrote in the chat, great way to show the process of taking raw data to an organized graphic.
Mm-hmm. All right. And it is. And so now we can move on to that whole concept, and we're going to look at that. So actually what I did is, I think I still have this spreadsheet up. I took the data from the website for all the states, and when someone made the comment, I love the comment, said they may not be able to really understand that that's 2 columns of data. And I don't think students learn enough about Excel in middle and high school. I really don't. And data is so important, and Excel spreadsheets are so huge for data, but also just personal finance. And so we can really use this opportunity in math to help them learn a little bit about Excel. So depending on what level you're teaching, but I was able to sort out and split out the numbers. And so what I was then allowed to do was, just with the Inspire, I could just take this data and dump it straight into a list and spreadsheet page. Functions just like an Excel spreadsheet. But one of the questions was basically, what states have the most electoral votes? So, you can come in here and say, well, gosh, it would be really, really nice if we could just sort that data, would it not? And so we can just do data and sort it. And let's put it in descending to look at the big guys. Okay, so that's out of whack. I made a mistake. I love to make mistakes because Alabama certainly does not have 55 electoral votes, but I can do Control Z and undo it. So what I need is I need to select both states. I mean, both columns, right? Because it didn't sort both. So I'm just going to kind of right click. I'm going to click data, sort. And it's saying that I want to sort by B and I want to sort in descending. Okay, so now why does California have the most electoral votes? Like that would be a great conversation to have with students. All right, and really connect that to population. So you could scroll down and then they could pick, we could pick Florida's at 29, tied with New York based on population. So really easy ways to take data, put it in a usable form for students, and then we can jump over to graphing. Before we do that, I just wanted to show, because I'm going to piggyback on this, I did run the statistics to show that our average is about, our mean is about 10.5 for this. You can see that right there. And then our median, which we'll see in a minute anyway, was 8. So I'm going to go ahead and put in a data and statistics page. And I don't know if any of you guys are, I'm sure y'all have heard of Geometry Sketchpad. That was a Key Curriculum Press. I think they're now with somebody else, but they had this Fathom Dynamic software. And I loved doing that when I taught middle school before the Inspire was around, because what it did with data was great. So we can come down here and we can just click these votes. And that matches that graph y'all saw when Ruthmae had that up there. So let's talk about this data. What do we notice? We can talk about the skewedness. So what's the skewedness? Any comments or anything in the chat? It's skewed to what? Skewed to the right, right? Because the tail's to the right. And so what would be better to represent, the median or the mean? And why? And so this was one of those questions that they had. And so this is one of the instructional tasks. So the Big M does a phenomenal job of giving just some big picture questions, which I think are awesome. And if you think about it, you know, California over here and Texas and maybe even Florida and New York, you know, they're messing this data up. So those big scores are going to affect that average more than that middle value. Think about that. Does that make sense? And we'll see that. So it would be really, really nice to look at a dot plot. I mean, to look at a box plot, right? So, and kids love this. So I can go to plot type and I can change box plot. And so we have that box plot visualization. And we can see that those are obviously considered outliers without really talking about IQR, because remember in 7th grade, we can, you know, depending on your level of kids. And what's nice is you can click in here and see too, like what's happening there. And what's really, really cool is you could grab this and say, well, gosh, what would we have to do to make something not an outlier? How much would we really have to change our data? And so all of these what if scenarios, and I can just do Control Z and undo that. But what's even more important is I think it's awesome to basically put two plots together. So down here, we can go ahead and do that. We can add our numerical values down here as well. And so the box plot should support the raw data, right? And again, just like when we saw on that other screen, you can see where those values are. And we can talk about the fact also with outliers is this is pretty much 75% of the data if we took out these three, right? And so, and then again, that discussion with outliers. But just some visual representations of students using the technology to create those graphs first as a concept, and then have them turn to paper and pencil. Of course, you may not want them doing 50 data points using paper and pencil, but comments or questions on that?
That in the chat, they were wild. So they questioned, what technology is this? I said, this is TI Inspire. So
this has been out for a long time. In all honesty, the first iteration they came out was big and clunky and not rechargeable. So there's an iPad app, there's student and teacher software, and there's also handhelds that you can put all these lessons on. And so all of our lessons and activities are free, and they are so incredibly pedagogically sound. And you can even use this as a demo as you want to. So, I'll put my email, or Ruthmae can drop my email in the chat box if she wants to, but it really is phenomenal technology. And to me, it's tough to beat doing data analysis and statistics on something that would beat the Inspire, just because this was created by teachers. They gave their input and turned it over to programmers. But any concepts or comments or anything with that? Anybody have anything to add about, how this would help address misconceptions? I know the teacher I was talking to about math for college readiness, when we did that simple one and just showed that interquartile range, she's like, oh my gosh, the middle 50%, this would help them so much.
Beth, I want to say that just the use of this technology, in teaching even the introduction to statistics, where students cannot seem to visualize, even when you have them draw it by hand, and when they make those mistakes with the data, having this representation will help them to defend their thoughts or ideas. If there's a misconception, they can go back again and look at where the error was, because this in itself presents the ideas so clear. When they're having issues, you can say, well, go back now, look at, if you have to put a number to the amount of data that was found in the first box or the first quartile, what thoughts would come to your head? And so, having students see it this way, and the questions that you as a teacher could generate from this, I think this is a great tool for us to be able to use.
And that's what's awesome with, you can just pick out, there's questions that go with this, but it's like you said, you can just use the technology and develop your own questions.
And I also want to highlight how the Big M actually acknowledged the benefit of technology. So they'll say, think about this or use technology. So Beth is providing a clear example as how technology can help students to read the language of mathematics. And so in this regard, they're not just looking at raw data, but they're reading different representations of the same data and even seeing it side by side. So it creates for crosstalk as to why they see it, what does it mean, but also they're reading language of math. And I think that in itself is a beautiful asset of using the TI Inspire to help advance those B.E.S.T standards as well.
Mm-hmm. Yeah, and I know that the folks at DOE too, we've had some discussion, and they want their focus to be on teaching and learning. And so it's not always about what technology you're allowed to use on testing. Just because, and I hopefully that'll change a little bit in Florida, because we are one of the few states that don't allow graphing. But I mean, you can use it on ACT and IB and SAT and all that, and APs. But the whole concept of utilizing technology to build understanding, if kids have this understanding, they don't need that calculator on a test to figure this stuff out, because they're not going to give them huge data sets, right?
Mm-hmm.
Questions?
To me, it does develop the understanding even a lot more, so that If you don't have the calculator, you can visualize within itself, if you're a visual learner, visualize what it should look like, right? And then when you have to do without the calculator, you have that, it develops that concept even more. So, you know, again, the tool of mathematics, the discourse itself helps with having the technology to help model some of those concepts for students, right? If they're not able to clearly visually see it and then identify those misconceptions that they may have. So I think, you know, I think something that I read earlier on, and I think it may have been in the Smith and Snide article, they were talking about that teachers should also be very intentional about the task that we select, right? When we have to teach a particular benchmark, be intentional about those particular tasks as well that you're going to select. I know in many cases, the curriculum is there and they have these ideas of what you should do. But I think also doing some more exploring yourself as to those tasks that are out there that warrant you identifying those purposeful questions and identifying those tools that you could use, technology, to help you with those concepts and misconceptions.
Yes. I want to extend that construct because when you think about the nature of the task, they can vary from levels of cognitive mind. Some are just memorization, procedures without connections, procedures with connection, and this construct of doing mathematics. But technology as a way to transform tasks. So like I can remember in P 1987 when you talk about technology can transform the mind. But fast forward to 2021, where we talk about the Samara framework, where we start off with substitution, augmentation, modification, and redefinition. So the way we think about this construct, or like we talk about the FCIT technology integration framework, where we can literally transform and create collaborative environments and really extend the nature of the task. So students can actually, this can fill many gaps actually, if done well. So when we talk about the vertical alignment and horizontal alignment, really thinking about how do we plug those holes for the misknowledge that occurred, you know, during those challenges during COVID-19. So technology provides that point of inquiry. It provides that opportunity for students to do some independent learning, but it also creates a space for engagement where students are more likely to take ownership of the mathematics. And so as Beth was providing those examples, like really talking it through, we took the same standard. We read the instructional suggestion, but yet we were able to make it our own and extend it based on this construct of how the tool could support that objective. And this is where planning is key. And really think about what are the questions was she asking? What is the nature of, what was the mathematical objectives? So it wasn't where the technology replaced it, but the technology enhanced and helped us to focus on the key finding. So it's so important that as we think about how the technology can mediate the learning experience, then and only then could we truly see the beauty of the space.
Yes, yeah. And I think just to piggyback too, like the proper use of technology, you know, in my mind, a piggyback is like, you know, maybe we could do this before, but this allows us to do it better and faster. And so, you know, as Ruthmae mentioned, you know, everybody's on a time crunch because kids, they miss so much. And so when you've got a tool that allows students to develop a better understanding and faster, think about how that's going to transform your classroom.
Yes. All right, so we're coming to the end. We have 5 more minutes of our presentation. You want to go to the next slide, please? Make sure we don't miss anything.
I think, yep.
Cover that, so you can skip. Yeah, so I want to zoom in on, if you want a copy of it, I could share it. The state of Florida actually offers support for the middle grades, kindergarten, K through 5, 6 through 8, and 9 through 12, as well as school district leaders or college persons who serve in that leadership role to really help develop your understanding of the BEST standards as well, because knowledge is power. And if you have the time, you know, to just check in to hear, what are they saying? What are they recommending? Because we're all in this together. And trust me, it's going to take a village for us to ensure the students in the state of Florida not just meet the standard, but they exceed the standard, because greatness is before us And as a collective, we can make this happen. And so we will continue to reflect on ways to ensure our students are meeting the standards, but also ensuring that we fill gaps and promote those vertical and horizontal alignment such that the learning trajectories of our students are uninterrupted and their pathways to success is inevitable. Last slide, please. So on the slide, I actually dropped in the chat the link for the survey, Your Voice Matter, Your Feedback Matters. And so we really, really appreciate if you take the time to give us feedback about the presentation and just let us know what could we do to make it even more meaningful to you.